Hello again. We are going to do 3-7 graphs of rational functions today. My big warning for you, it's on top in red for a reason. These graphs are going to be rough sketches. That's okay. All right? So don't worry about making it perfect exactly like the graph. You don't need 100 points to prove that you did it right. That's okay. You'll see what I did. You'll see me doing them. And if it's a little rough, just go with it, okay? All right, so there are two ways to do these rational functions. The first way is to transform the parent function of 1 over x, all right? The second way to do it is to use holes, vertical, horizontal, and slant asymptotes. We'll go over all of that, all right? So, number one, transform 1 over x. Well, first of all, we need to draw 1 over x. 1 over x looks like this, okay? So if you plug a 1 in, you get a 1. If you plug a 2 in, you get a 1/2. If you plug a 1/2 in, you get a 2. And if you plug in a 0, 0 is not going to work, all right? So this right here is going to be a horizontal asymptote. A vertical asymptote. Whoop. And this right here is going to be a horizontal asymptote. And then this just skirts along this line, what I mean by rough right there. I got some points, but I just threw it on there, okay? So let's try it on -1. So if you throw in a -1, it'll be -1. A -2, it'll be -1/2. And a -1/2, you'll have a -2. Can't even figure out the angle I want to get this. Okay, so there you go. That is the graph 1 over x. Reminder for you, graphs have arrows on the ends of them. Okay, I'm going to start taking points off on tests and quizzes if you do not have arrows on the ends of your graphs. Unless it tells you not to, your graphs need to have arrows. Same with your axes, okay? Please don't be lazy mathematicians when you graph. Make sure your graphs are accurate. So this one has a horizontal asymptote. We said it, but I'm just going to write it down. So horizontal asymptote at y equals 0. And it has a vertical asymptote at x equals 0. All right. And we could mark down these points, but I think you got those. All right, so that's our parent graph for 1 over x. So we're going to look at 2 problems. I think I can fit them both on here. Perfect. And it says graph -1/2 x. Okay. So first of all, remember when we have a negative in front, that means it's going to, usually it flips it. In this situation, it's going to flip it into these quadrants. Okay. There's nothing added or subtracted, so we're still going to have the same asymptotes. And if it was me doing this one, I would legitimately just plug in a number. So if I plug in a 1, I'm going to get a -1/2. If I plug in a 2, I'm going to get -1/4. If I plug in a 1/2, okay, we know we're going to be heading this way. So I'm going to be done. I'm going to call my graph that, and that's okay. All right, if I plug in a -1, I'm going to get a +1/2. If I plug in a 2, I'm going to get a +1/4. And there's my graph. That way. Done. See what I mean by rough sketch? I have some points that work. I know which direction it's supposed to be in. I know where my asymptotes are. That's fine. All right, this one's going to be a little bit different because we got to think about it because we're going to be moving things around a little bit. Okay. First of all, we are moving our graph. Well, we have this negative, so we know it's going to be in these quadrants again. Okay. The second thing we know is that we need to move pretty much our axis to the left 2. Because that 2 is next to the x, we do the opposite. And we need to move it down 4. 1, 2, 3, 4. I don't even know if I'll be able to graph the bottom half of my graph because of where I put my axis. Okay, that's usually not okay. It'll be okay for right now. Okay. All right. So I might plug in a number because something's going on here. So what if I plug in a 4? 1, 2, 3, 4. I plug in a 4 here. I'm going to have negative 6 over 6 is negative 1. Minus 4 is negative 5. Whoops, no. I'm going to try that again. So I'm going to have negative 6 over 6 is negative, oh my goodness. Okay, let me plug it in because now I'm having a problem. So I got 1, 2, 3, 4. So I'm going to plug in negative 6 over negative 4 plus 2 minus 4 is negative 6 over 2 minus 4, negative 3 minus 4. But this bottom is negative, so that's going to become a positive. So that's a negative 1. So over negative 4, 1, 2, 3, 4, we're going to be a negative 1. Okay. And what if I plug in a 3? So I'll have negative 6 over negative 3 plus 2 minus 4. That'll be negative 6 over negative 1. So that one's a positive 2. 1, 2, 1, 2, 3. So it looks like I head up, and then at some point I start curving down. So these are going to be the same on the top and the bottom. So from this line, I would go over 1, 2, and up 1, 2, 3. So 1, 2, 1, 2, 3. So that would kind of be my point, which I would make my other part of my graph off of. Okay. But you can't even see it because I've taken over the graph below. All right, so that's a sketch of our parent graph. So the next part says, write an equation using the parent graph, y equals negative x. So let's take a look at where this thing moved. First thing I would do is figure out where your asymptote should be. Wherever that line kind of stops crossing, that's going to be your asymptote. All right, let's take a look at our equations. Our normal equation is that we're at 1, 2, and a half, and that looks like that's where we are. So we know we don't have any number multiplying by it, but we need to figure out how this moved. So we moved to the left 1, 2. So that means next to the x, we need to do a plus 2 because we went in the opposite direction. And did we go up and down at all? Doesn't look like it. So that is our equation for this picture. All right, for this picture right here, so same thing again, I'm going to figure out where my asymptotes are. So they look like they're right here because we are skirting along this number. Right here, we kind of come to a stop. They can't go anywhere. All right. Okay. So first thing we need to look is our x's. Where do we go? We go over 2. So that one's going to be a -2 because it's always opposite direction. Then do we go up and down any? Yeah, it looks like we go down 1, 2, 3. So then at the end, we're going to add a -3. These rules are the exact same rules as parent graphs from earlier. Anything on the end is the y change. Anything next to the x is the x-axis change. And that's it. That's your answer. All right. So now we're going to flip to the other new page, and we are going to talk about how we graph using different things. So, for example, how do we graph using holes, vertical asymptotes, horizontal asymptotes, and slant asymptotes? So I have something like this, and it says graph. I don't see a parent graph in there that I can just do. So we got some work. All right. The nice thing is there are steps. So step number 1, find if there are factor to find holes in vertical asymptotes. So we're going to factor the top. Okay. So we got an x. What numbers multiply to make 3, but add to make 4? Well, that's a nice and easy one. So we have 3 and 1. On the bottom, there is an x in each piece, so we can pull an x out. And then we can factor the leftovers. So our leftovers would be x squared plus x minus 6. I'll write it out so you can see it. Okay, so let's factor this. 2 numbers that multiply to make -6, but add to make a +1. So 2 numbers that multiply to make 6 would be 3 and 2. And one of those has to be negative. This needs to be positive. So our 3 needs to be positive and our 2 needs to be negative. All right, so once you've factored, you got to look for holes and vertical asymptotes. A hole is where the top and the bottom cancel out. So right here, these cancel each other out. So that means that there's going to be a hole at x equals -3. Why? Because if we made put a -3 in here, that would become 0. But because they canceled out, that means that there is a hole at that spot. Right? Vertical asymptotes are going to be where the bottom factors equal 0. So this right here would be x equals 0. And to make this 0, x would have to equal 2. All right, I know we're digging back into last year. All right, so that's the first thing we look at. We can ignore that for now because we need more information before we use that. Actually, that's not true. We could add our vertical asymptotes to the picture. Okay, so let me grab a color. Our vertical asymptotes are going to be at 0. So I'm going to make dotted lines at 0. And at x equals 2. So we know we got something funny going on here because we have 3 sections to our graph. Okay. All right, number 2, use division to find horizontal or slant asymptotes. So it's probably been a little while since you've done long division with factors like this. All right, so we're gonna do x cubed plus x squared minus 6. Remember, the bottom number goes outside and the top number goes inside. Okay. All right. can that x cubed go into our x squared? No, it cannot. So that means that this cannot go into that anytime. That means we have 0. So our horizontal asymptote is 0, or I'll add y equals 0. Okay, and then if there are no horizontal asymptotes, then you have a slant asymptote. Right? So that means I'm going to add at x equals 0 my horizontal asymptote. And there is none of these, because there was one of those. Okay. Plug in a couple points to sketch. So now we got to figure out on our graph here where these points go. So I'm going to plug in, here's my new equation because of this hole right here. I have an x plus 1 over this factored is x squared minus 2x. So I'm going to use this to plug in my points, okay? So I'm going to use points, I'm going to use okay, that was for a different problem. I was trying to see what's going on here. I'm going to use points. I'm going to plug in maybe a -2, -1. Oh, I need to know what's going on at -3 because there's a hole there. 1, 3, 4. Okay, so a bunch of points. And this should be quick. So -3 minus 1 is, or you could even do it in your calculator to make it go quicker. Let's do that instead of in our head. Okay, so we have x plus 1 divided by x squared, whoops, squared minus 2, let's do times, okay, so that is, turn that to a fraction for us, it's -2/15. Okay, now I'm going to plug in a -2. Okay, so I think that's like -1/8. If you weren't sure, you could do a fraction. Yep. Okay. Let's plug in a -1. That's 0. All right. You might be asking, why in the world did she pick these numbers? Okay, I picked them because my asymptotes are here. So I picked a couple numbers to the side of my asymptotes, one in the middle, and then a couple on this side. All right. So those are all the points that I picked on this side. So I could plug them in. All right. So at -1, I am at 0. Okay. At 2, I'm at -1/8. I'm getting closer. Okay, remember there's a hole at 3. This one's really funny because it's down here and it went back up. All right. So actually this one does something silly. It skirts along the bottom of this asymptote. Okay. Horizontal asymptotes are funny things. They don't have to you can cross horizontal asymptotes. You cannot cross vertical asymptotes. I'm going to plug in -0.5 because I'm not 100% sure what is going on. I'm not really sure what's going on up here. Oh, it's 0.4, so it looks like that one's positive, and it goes like that. but I wasn't quite sure, so I decided just to plug one more number in. Okay, now let's do the same thing and plug in a 1 to see what's going on at 1. Okay, so that is at -2. So at 1, I'm at -2. Okay. Usually when there's 1 in here, it doesn't cross this line. So our picture is going to probably look something like this. Okay. It's not going to, it can skirt a horizontal asymptote, but it cannot just cross it and ignore it. So that one has to go down. And so now let's plug in 3 and 4 to figure out what's going on there. And 4. Okay, so at 3, I'm at 1 here. At 4, I'm down here. So we must look something like this. And there's your picture. Okay? Yeah, it was a lot of work, but we got our picture. All right. Okay, one more problem. Graph this. All right, so let's work through this one together. We got to look for all of our pieces. So problem number 1. Is there a hole? Okay. Well, I don't know. Let's factor it and see. Can we factor this? You're going to take some time looking, and you're going to see that no, we can't factor it. So no, there's not a hole. Okay. Is there a vertical asymptote when the bottom is equal to 0? So yes, at 2. Okay, so now let's look for horizontal or slant asymptotes. So I'm going to put the bottom number out here. And I'm going to put this number here. Okay, so what we're going to do is we're going to look, can x go into 2x squared? Yes, it can. It goes in 2x times. Okay. And then we multiply these two, so we'll have -4x. And we'll subtract just like any normal equation, so that'll be subtraction. This would become a positive, so I'll have plus x. Bring this down, +1. Can x go into x? Yes, 1 time. So then we'll multiply back out x, -2. And we have left -3. Okay. This right here, if this is a number or 0, that's your horizontal asymptote. If this is an equation, this is going to be a slant asymptote. All right. So what we're going to do is we have a vertical asymptote at x equals 2. We have a slant asymptote at this, so we're going to go to 2. We're going to go up 2 over 1, up 2 over 1, 2 over 1, 2 over 1. We're going to make this a dotted line because that was my slant asymptote. Okay. Then we got to pick some numbers to graph it. That's all we have left because there's no hole to worry about. So if we plug in let's plug in a 1 and figure out what's going on when we do that. So if we plug in a 1, we'll have 2 minus 3 plus 1. So that's 0 over something. So that's 0. So that goes here. Okay. What if we plug in 0? We'll have 0, 0, 0. So negative a half. So my picture's going to look something like this. Rough. That's okay. All right, so then let's plug in a 2, let's see, 1, 2, 3. Oh, I don't want to do that. Okay, I'm going to plug it in on here. So I'm going to do 2 times 3 squared minus 3 times 2 plus 1. 3 minus 1 is 1, so 13. Right? 1, 2, 3, 4, 5, 6, 7, 8. Why did I get 8? Last time when I did it, I got 8. 1, 2, 3. And I plug that in right? 3 squared. Oh, nope. I didn't. This should have been a 3. That time I got 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That looks like about right. Okay. And then it's going to go something like this and this. All right. So that's what it looks like. What does it look like if we find a horizontal asymptote? I'm going to do a problem for you right down here. I'm just going to do an add-on. Okay, so I have 3x minus 1 over x minus 2. Okay, find the slant or horizontal asymptote. So what I'm going to do is my x minus 2 goes outside. My 3x minus 1 goes inside. X goes into 3 times. And I have 3x minus 6, 0, and this is a plus 5. All right. Can't go into it anymore, and I just have a 3 left. So then y equals 3 would be your horizontal asymptote. Your horizontal asymptote. Okay. It doesn't matter whatever is left over. We don't care about the leftovers. We just care about what's on top. Okay. All right. This is your homework assignment, page 186, number 15 to 41 odd, and 56. Let me know if you have any questions. I know this had a lot. I'll talk to you guys later.